Welcome back to the deep dive. Today we are opening up the official strategic blueprint for what might be one of the most ambitious infrastructure projects on the planet.
It really is. We're talking about the Cloud Control Platform, or CCP Technology Roadmap 3.0.
And our mission today is to give you that consultancy-style breakdown. We've gone through the source documents, the planning reports, and we're going to unpack its current status, where the critical gaps are, and the incredibly rigorous milestones they've set for the next 20 years.
And to set the stage for you, it's probably best to think of the Cloud Control Platform as the integrated brain and really the central nervous system of what they call the Vehicle Road Cloud System.
VRC.
Exactly, VRC. It's the architecture that lets intelligent vehicles talk to the road, to traffic management, to the energy grid, you name it. It's not just about smart cars.
Yeah.
It's about creating a single, massive, intelligent operating system for the entire transportation ecosystem.
And we're going to stay strictly analytical here. We're tracking a huge three-phase evolution. First up is standardization by 2030, then scaling up to a national level by 2035.
The whole country.
And the final goal, achieving global tech leadership by 2040. So if you want to understand the future of integrated mobility, this is really it.
Well, the need for the CCP is, at its core, strategic. It's driven by economics, national security, and environmental goals.
Right.
And the whole platform is built around one key philosophy: layered decoupling and cross-domain sharing.
Okay, let's pause on that. Layered decoupling sounds like some serious technical jargon. What does it actually mean in practice?
It's the key to the whole thing, really. It delivers modularity. So think of it like the operating system on your phone, iOS or Android.
Okay.
The core of that system is stable. It's predictable. The decoupling part means that the apps you build on top, say a new automated driving feature or a smart traffic light controller, they can be developed and updated on their own.
Without breaking the whole system.
Exactly. Without destabilizing the core platform.
Mhm.
It's designed to prevent vendor lock-in, which is a massive problem in these huge infrastructure projects.
So it creates an open market on a shared, really robust infrastructure.
Precisely. And this setup provides what they call network empowerment for three big areas: vehicle operation, traffic management, and, maybe most importantly for the future, industrial digital transformation.
So we have three strategic pillars propping this whole thing up. Let's dig into the first one, guaranteeing industrialization and commercialization.
So the CCP is really mandated to create value quickly. It enables the real-time sharing of road infrastructure and crucial traffic data across what are normally competitive boundaries.
So it breaks down the data silos between, say, different car manufacturers or logistics companies.
Right. And by gathering all this super detailed real-time data on a citywide scale, the platform just elevates the decision-making of every intelligent connected vehicle, or ICV, on the network.
Because a single vehicle only knows what its own sensors can see.
Yes. And the CCP gives it that global view. It provides data comprehensiveness, timely processing, and critically global decision-making.
So it knows what's happening miles ahead or around a blind corner.
Or across 50 synchronized intersections. And that external intelligence is what really accelerates the industrialization of automated driving. It moves you from just local optimization to system-wide efficiency.
Okay, pillar two. This one ties directly into national strategy. Building a manufacturing power and a transportation power. How does the CCP fit in there?
This is where it gets really explicit. By modernizing the whole transportation system, the CCP shifts it from being reactive, responding to traffic jams, to being predictive and optimized. It leads to a better public travel experience, less time in traffic, and huge gains in efficiency. For manufacturing, that data loop lets you optimize supply chains with incredible precision. It's infrastructure as an economic catalyst.
And the third pillar, the dual carbon goals, connects this to sustainability. I think most people think of electric vehicles, but how does a cloud platform actually improve energy efficiency?
It's all about optimization and cutting out wasted movement. So first, it uses real-time vehicle data to create energy-saving driving algorithms for the car.
So it tells you the optimal speed, when to accelerate.
Exactly. But the big win comes from managing the macro flow. The cloud can predict and alleviate congestion before it even forms.
Which means less idling.
Way less idling,
Yeah.
which means lower carbon emissions. The goal is to basically eliminate the stop-start city driving cycle. It's sustainability through data.
So you've got safety, economic strength, and sustainability all in one platform. That brings us to the update. Why the revision from version 2.0 to 3.0?
Well, the revision was needed because the first build-out phase was, in many ways, a success. They got a lot of real-world experience at the city level.
So 2.0 was the test run.
You could say that, yeah.
Or,
2.0 was about validating the concept.
yeah.
TRM 3.0 is the pivot to, let's say, performance execution and industry consensus. The new roadmap is much more specific. It drills down into system architecture, applications, testing, areas where standardization was kind of lagging before.
And that means more precise, quantifiable metrics.
Exactly. It formalizes this consensus structure. Cloud control basic platform plus cloud control applications. And that split is important.
How so?
It ensures the basic platform just focuses on being a high-performance, standardized infrastructure, the pipes, the storage, the core services. Meanwhile, the applications layer is all about delivering measurable value to users and businesses. It reflects a maturing industry.
All right, so to really understand where this is all going, we need a frank assessment of where it is right now. Let's look at the successes of TRM 2.0 before we get into the pain points.
Okay, so the initial infrastructure build-out was, highly successful. They have regional CCPs up and running in over 10 major cities, Beijing, Shanghai, Wuhan Plus on several major expressways. The original 2025 goal for just getting the regional platforms built and running some exploratory operations was by and large met.
And the numbers on the roadside infrastructure deployment, they look pretty big.
They are. They actually blew past the 2025 target. The goal was for at least 1,000 roadside systems.
And the actual number?
The latest reports show around 3,000 roadside collection points and over 6,000 roadside units. So this massive physical network is in place. It provides the redundancy and the beyond visual range sensing you need for, basic L3 automated driving. The foundation is there.
Okay, so they built the digital roads, but getting the cars to actually use them, that seems to be a different story. Where are the critical performance gaps that 3.0 has to fix?
This is the heart of the issue. The biggest challenge, the one that really threatens the whole 2035 national scale goal, is the gap between building the infrastructure and getting commercial at-scale adoption. That plus a severe latency hurdle.
Let's start with that scaling gap. The numbers I saw, the difference is it's staggering.
It's the most stark metric in the whole assessment. The TRM 2.0 goal was to have at least 500,000 vehicles connected by 2025.
500,000. Okay.
And the reality?
The current reality, and this is combining all the pilot cities, is only around 10,000 vehicles.
10,000. That's not a gap, that's a canyon. It's a 50-fold difference.
This is a 50x gap. That sounds less like a technical problem and more like a commercialization failure. Why aren't the vehicles connecting?
It's complicated. It's not just one thing. You have regulatory slowness in mandating this stuff. You have resistance from the auto OEMs.
They don't want to share their proprietary data.
Of course not. Not with a central platform. There are huge competitive concerns. And then there's just the cost. Retrofitting old cars is expensive, and adding the CCP-compatible hardware to new ones isn't free.
So TRM 3.0 has to pivot from what to build to how to get people to actually use it.
That's the core challenge. Until they solve that adoption problem, all this great infrastructure is just sitting there, underutilized.
And then there's the other problem, the latency gap.
Yeah.
The speed of the system.
The low latency hurdle. This is fundamental for safety. For collaborative maneuvers, L3 and up, decisions have to be almost instantaneous. And right now, they're not.
How far off are they?
Well, for data collection and distribution latency, the current performance is less than or equal to 80 milliseconds. The goal for 2025 was under 20.
80 milliseconds. That doesn't sound like a lot, but at highway speeds, that's a car traveling several meters.
It's a disaster waiting to happen.
Mm-hmm.
If the cloud is involved in, say, collision avoidance, that delay makes the cloud a liability, not an asset.
Wow. And what about the computation latency?
Same story. Current reality is under 50 milliseconds. The goal was under 30. So that latency introduces an unacceptable amount of risk. The entire roadmap from here on out is an aggressive plan to crush those numbers.
Because they realize you can't get to real autonomy with those kinds of delays.
You can't. Not with the traditional cloud model. It requires whole new architecture.
Okay, so let's compare that architecture globally. On paper, China's vehicle road cloud integration concept seems more, holistic.
It is. They got a big first mover advantage by defining this comprehensive system-level architecture back in 2020. It's a top-down approach.
How is that different from what's happening in, say, Europe or the U.S.?
Their programs, C-Mobile in Europe, or CIT in the U.S., they've historically been more fragmented, more vehicle-centric. They prioritize making the individual car smarter with some localized roadside help. The cloud is often just for storage or non-critical services.
So they build out from the car, whereas the CCP builds inward from the entire system.
Exactly, which makes it much easier to mandate that cross-industry, fusion vehicle, traffic, energy, all of it.
But having a great blueprint doesn't help if you don't have the computational muscle to power it. The sources identify a major deficiency here, a computing power lag.
And this is probably the most serious strategic vulnerability they have. The data shows that the country's total computing power, even if you add up the three major operators, is only about half of what a single integrated competitor like Tesla has.
Tesla is cited at 100 EFLOP-PS. Can you put that number in perspective? It's abstract.
It's an insane number. An EFLOP-PS is an exact floating point operation per second, and a GAC is 10 to the power of 18. So 100 EFLOP-PS is 100 quintillion calculations every second.
My brain just short-circuited.
It's the raw power you need to train the enormous AI models that are the actual brains of these autonomous systems. Being at half the capacity of one competitor doesn't just mean you're slower. It means you can't train models that are as complex or as capable. It's a fundamental AI brain gap.
Which is a direct threat to that 2040 goal of global leadership.
A massive one. And on top of that, there's an efficiency lag. Domestic smart cluster utilization is lower than at places like Google, who are getting around 40%. And even the accuracy targets for perception are a bit lower, 95% versus 99.5% elsewhere.
So the takeaway is pretty clear. TRM 2.0 built the roads, but 3.0 has to conquer two massive challenges: getting commercial buy-in at scale and securing AI computational supremacy to solve that dangerous latency problem.
That's the mission. And that brings us to the future state. TRM 3.0 is a hyper-aggressive roadmap designed to do exactly that.
So let's start with that end state. What is the grand vision for 2040?
The goal is a global reaching, intelligent connected vehicle, big data CCP. And the strategic mandate is to completely dissolve the operational silos between four critical networks.
Okay, what are they?
The vehicle network, the intelligent traffic network, the smart energy network, and the collaborative information network.
Total integration. And what does that actually look like when it's all put together?
The synthesis is what they call intelligent vehicle, digital road, interactive energy, collaborative cloud. Every piece of the puzzle, from a car's motor to citywide energy use, is integrated and managed by this one cloud brain.
Okay, so let's break down the three phases to get there, starting with the most immediate, the goals for 2030.
Right, phase one. This runs from 2026 to 2030, and it's all about standardization and regional coverage. The goal is to build a fully standardized CCP.
So fixing the fragmentation from the pilot phase.
Exactly. Unified standards for hardware, data, software. For coverage, they're targeting 90% of first and second tier cities and 20% of expressways. And for service, this is key. They need to show market penetration.
Get people using it.
Right. Collaborative Advanced Driving Assistance Systems, CADS, in L1 and L2 vehicles has to hit at least 50% market penetration. And the more advanced version, CDS for L3 and up, needs to hit 30%.
So by 2030, this thing has to be a real widely used product. Then we move to the midterm, 2035. This is where it goes from regional to national.
This is phase two, national scale and L4 support. The goal is a unified, national-level CCP integrating all those regional platforms.
And the coverage expands massively.
Massively. 90% of first, second, and now third-tier cities, plus 50% of expressways. This brings rural and long-haul transport into the grid.
And the service penetration targets.
CADS jumps to 80% or more. CADS for the automated vehicles hits 60%. And the key technical focus is on hardware that supports software definition and hardware acceleration. The system has to be dynamic, adaptable, to enable commercial L4 autonomous driving.
That jump to L4 is huge. That's the vehicle handling everything in certain areas that requires absolute guaranteed reliability from the cloud.
It does, which is what the final phase is all about, 2040.
Phase 3, long-term, 2036 to 2040. Global reach and full autonomy.
The goal here is a global CCP. The focus shifts from just domestic integration to exporting this as a blueprint. Coverage hits 100% of cities at the county level and above.
Total saturation.
Total. Service penetration for CADS and CADS hits virtually 100%. It becomes a standard, like seatbelts. And the technical focus is, it's about sovereignty.
What do you mean?
The system must rely on fully self-controlled large model training and inference chips. They have to secure chip sovereignty and computational superiority, supporting full autonomy without any reliance on foreign tech.
If they hit 100% penetration, that means vehicle autonomy in this economy is fundamentally tied to this centralized cloud. That completely redefines how autonomy even works.
It creates an incredible network effect, a moat. Every new car, every new sensor makes the central intelligence smarter, faster, more reliable. Something a system based on vehicle-only intelligence could never compete with.
All right, that's the strategy. Now we need to get into the weeds, the 5 technical roadmaps that make it happen. Let's start with Roadmap I, the architectural blueprint itself.
So the big challenge here, as we saw from the TRM 2.0 critique, was just managing complexity. You have people, vehicles, roads, cloud.
Yeah.
It's a massive system of systems. The old way of using static documents just doesn't work.
So the solution is a shift to model-based systems engineering, MBSE. What does that mean for you listening at home?
MBSE means you shift from static documents to a dynamic digital model, a living digital twin of the entire VRC system. Instead of paper specs that are instantly out of date, the design is codified in a model you can test and verify. You can simulate everything before you build anything.
Sounds essential for a project this size. What are the measurable targets for this?
They focus on flexibility and speed. First, decoupling and iteration. The cloud control module decoupling rate has to go from 3 in 2030 to 5 by 2040. Higher number means more independence, easier updates. Functional module reusability needs to hit 80%. But the craziest target is the single round iteration time.
How fast?
Down from 10 days in 2030 to just 5 days by 2040.
5 days to update a critical component in a nationwide system controlling vehicle safety. That's only possible if that MBSE framework is flawless.
It's the ultimate test of their architectural efficiency. Integration has to be almost plug and play. And to support that, the number of defined functional sets has to double, and the number of standardized information flows has to hit over 500. This is about eliminating any ambiguity in communication. Everyone speaks the same language.
Okay, that brings us to Roadmap 2, the core engine, the shared services. This has to directly tackle that latency gap we talked about.
It has to. And it's organized around 5 standard components, starting with how the system sees the world.
Which is fusion perception technology.
Right. Knowing the world. It's about fusing data from vehicle sensors, roadside LiDAR, cameras, everything, to build a perfect real-world picture.
Yeah.
The 2040 target for position accuracy is less or equal to 20 centimeters. That's the difference between success and failure in an L4 maneuver.
And the most aggressive target in this entire document is in the next component, right? Collaborative decision technology.
Making fast choices. This is where it gets wild. The 2040 target for the decision correctness rate is over 99.9%. But the headline number is the latency.
Go on.
Real-time decision time has to drop to less than or equal to 5 milliseconds.
5 milliseconds.
Down from 20 in 2030 and the current reality of 80. For context, the fastest a human can react is around 100 milliseconds. This is almost instantaneous.
Let's talk about that 5 millisecond target. Is that even physically possible? We're not just talking about sending a data packet. This is collecting vast amounts of data, running AI models, calculating trajectories for multiple vehicles, and sending that decision back, all in 5 milliseconds.
It's what they call an existential necessity, masquerading as an ambition. For L4 autonomy to work safely in dense, high-speed traffic, the cloud cannot be the bottleneck. It's the non-negotiable threshold. To get there, they need breakthroughs in everything networking, edge computing that pushes processing power right to the roadside. If they miss this target, the whole national L4 deployment under this framework, it can't happen.
Which puts a ton of pressure on the next 2 components, control and traffic management.
It does. Collaborative control is about acting in concert, synchronizing signals to the vehicle, the traffic light, everything. The end-to-end latency there has to be under 20 milliseconds by 2040. And for traffic management, they need to model hybrid traffic flow, the mix of connected and non-connected cars with 99.8% accuracy.
Is there a tangible outcome for the public there?
Yes. The average vehicle speed on main city roads during rush hour must increase to 45 kilometers per hour. That's a real measurable improvement in quality of life.
And finally, the data itself.
Domain big data analysis. This is about handling the fire hose of data and using AI to mine it for high-quality, rare scenarios you need to train the L4 and L5 driving models. By 2040, this has to improve training efficiency by 90%. It's about making the whole system smarter, faster.
We've covered the blueprint and the core performance. Now we need to talk about the raw horsepower to make it all work. Roadmap 3, the computing engine, designed to close that power gap.
The challenge is still that massive demand for compute. And the goal is computational sovereignty, full stop.
And the strategy is to achieve parity or even superiority with the big international cloud players. How do they measure that?
It's all about efficiency. Smart compute cluster utilization has to jump from 30% in 2030 to 70% by 2040.
70%. That's almost double the current international benchmark.
It's incredibly aggressive. It means a highly optimized system. The system also needs to handle 1 million concurrent connections by 2040, and cloud data storage has to happen in under 10 milliseconds.
What's the incentive for companies to use this platform?
Economics. The targets for both efficiency improvement and cost reduction are 50% by 2040. It has to be not just technically better, but cheaper.
And that brings us to the geopolitical part. The requirement for self-controlled domestic AI chips. Why is that so critical?
It's about eliminating that strategic vulnerability. You can't have a critical national infrastructure project reliant on foreign supply chains for its brain. This is about achieving AI sovereignty. They need to be able to train and run their own complex, industry-specific, large models without any external reliance.
And what will these large models actually do with all that power?
They move the intelligence from just controlling one car to managing a whole city. The number of AI-supported scenes skyrockets from 10 in 2030 to over 100 by 2040.
Scenes like what?
Like predicting how a sudden snowstorm will impact traffic across the entire city and rerouting thousands of vehicles proactively, or optimizing the energy grid based on real-time traffic load. The large model throughput has to improve by 200% to support that kind of complex predictive thinking.
Okay, so that's the engine. RoadMap 4th is the commercial reality. Check the applications. This has to solve that 50x scaling gap.
Right. This is where the rubber meets the road, so to speak. It's about delivering undeniable value in 3 categories. First is ICV empowerment for the vehicles.
D80S and C8S.
Exactly. By 2040, it has to support over 200 application scenarios. And the key metric is that the average data adoption rate by vehicles has to be over 99%. The cloud data has to be integral to the car safety systems.
Next, the value for cities and governments.
Traffic management and control. The 2040 goal is over 100 different management scenarios, and the measurable public outcome is a 25% improvement in average road network efficiency.
A quarter less time stuck in traffic. That's a huge payoff.
It is. And finally, data empowerment. This turns the CCP into a data resource for other industries.
Logistics, insurance.
OEMs, research, you name it. The goal is to provide 500 different application scenarios for other industries. That's a 10-fold increase from 2030. That's how you generate the revenue to sustain this massive investment.
And the final piece of the puzzle, RoadMap V comprehensive test and evaluation, the quality gate.
You can't scale a safety-critical system without proving it's reliable. And current testing is too slow, too expensive, and just can't cover all the weird edge cases.
So they have to transform the whole testing paradigm.
Completely. They're moving away from physical testing toward virtual validation. First, they're automating software testing. The intelligent test coverage rate has to hit 80% by 2040, using AI to generate test cases and remove human bottlenecks.
And to make simulations more real?
They're mandating virtual real integration testing. So you run digital models in parallel with real-world data feeds. This lets you test dangerous or rare scenarios safely. And the key asset here is the test scene library.
How big does that get?
It has to reach over 200,000 scenarios by 2040. That's the library you need to prove L4 and L5 safety across every conceivable edge case.
And how do they measure the quality of the whole system?
Through a multi-dimensional evaluation indicator system. The number of indicators goes up 4-fold by 2040, and the focus shifts from just basic functions to measuring large-scale performance and robustness under extreme stress.
And finally, they have to harmonize all of this.
Exactly. The local variation between the city platforms is a huge problem. So the 2040 target is to synthesize everything into one comprehensive CCP evaluation standard system, a single, unified quality gate for the entire nation.
Okay, we've gone deep into the 5 roadmaps. Let's zoom back out. What are the big overarching trends that define this path forward?
I'd say there are 5 converging trends, and they all come back to solving those core problems of integration and scale. Trend number 1 is the systematization of architecture design. The takeaway is that complexity kills scale. So the adoption of model-based systems engineering is non-negotiable. It's the only way to manage the integration and hit that 5-day iteration cycle.
So the architecture itself becomes the tool for rapid deployment.
Precisely. Trend 2 is the standardization of core capabilities. This is the direct answer to the 50x scaling gap. They're creating mandatory standard components, fusion perception, collaborative decision, as the building blocks for every platform. This stops fragmentation and lowers the barrier to entry for everyone.
Trend 3 has to be about the compute deficit and the latency barrier.
Absolutely. Trend 3 is model-based information infrastructure. This is the big paradigm shift from generic cloud services to a specialized infrastructure built around their own autonomous, industry-specific large models. This is how they plan to close the EFLOP-PS gap and hit that sub-5 millisecond decision time.
It shifts the competition from who has the biggest data center to who has the most efficient AI.
Exactly. Trend 4 is scale-up application deployment. We're past the pilot phase. The trend is now compulsory, commercialized, city-level deployment. They have to prioritize apps that show immediate, measurable value, like that 25% traffic efficiency boost, to drive adoption.
It has to prove its value or it won't get used. Makes sense.
And the last one? Trend 5, systematization of testing and evaluation. This is about guaranteeing reliability for that mass deployment. It requires national standards, that massive test library, and hybrid testing. You just can't get to national L4 support without a bulletproof quality gate that builds public trust.
So to wrap this all up,
In closing, I'd say the CCP Technology Roadmap 3.0 is this incredibly comprehensive 5-in-1 blueprint for a massive national system integration. The last phase built the physical roads. The next 2 decades are all about tackling the 2 biggest gaps, hitting that insane low latency target and bridging the huge commercial scaling gap.
it really seems like the whole journey to intelligent vehicle, digital road, interactive energy, collaborative cloud is just a mandate to break down these huge entrenched industry silos vehicles, traffic, energy, data, and merge them under a single hyper-efficient computational brain.
And its success is going to be determined by whether they can turn these ambitious targets into real-world execution, especially getting that 70% compute utilization and securing their own AI chip supply.
This is so much more than a technical plan.
It's a commitment to a future where systemic intelligence is what drives safety and efficiency.
Which leaves us with our final provocative thought for you, the learner. If the ultimate measure of this kind of networked intelligence is its speed and reliability, just think about the strategic implications of winning the race to 5 milliseconds. If a cloud brain can guarantee a correct, globally optimized decision faster than a human heartbeat, how does that completely change the competitive landscape for every automaker on the planet? And if this platform is designed to support 500 different industry applications, what kind of new trillion-dollar industries might emerge when that guaranteed real-time zero-latency data stream becomes a common public good? That level of integration doesn't just change the game, it creates a whole new one.